Hello, Chemistry 11 Honors. This is Mr. Chan, and this is just a follow-up on the states of matter introduction that I had talked about last day. Recall when we talked about the states of matter, we talked about the difference between solid, liquid, and gases, and we talked, excuse me, about some of the concepts here in regards to the phase changes, superheating, supercooling, and the idea of evaporation, boiling, normal boiling point, that sort of stuff. Now, what I wanted to do today for this lesson is just to make reference to some of the textbook pages in your textbook. So if you turn to page 188 in your textbook, what they do is they give an explanation of what pressure is, and they give you the background in terms of the barometer. Now, one of the things that I wanted you to be aware of is if you take a look at this picture down here in regards to A and B, and if you read to the side, gives the explanation of why a can, when it is cooled in a sealed vessel, why does it get crushed? And the reason being is not because a vacuum is created, but what it is that the pressure outside the can is actually larger than the gas pressure inside. And that is what crushes the can. All right. And here on page 189 in your textbook, what you can do is read over in terms of, what is a manometer, what are the units of torr or millimeters mercury. And again, they give you a diagram similar to what I had done in your notes. As well, if you take a look on page 190, what they do is they talk about the pressure is equal to force divided by area. And they go over an example of simple conversion between one unit and the other. This is something that I'm going to definitely do ask you to practice is, are you able to flip between the units of things like atmospheres, pressure, torr, and so on. So you should be able to, when we talked about pressure, you should be able to flip between one unit to the other. The other thing I would like you to be aware of is if you turn to page 489 in your zoomed all text, what it does is that it talks about the change in state. And if you take a look on page 489 and 490, they do talk about the phase change for water. Now, one thing I would like to highlight on page 490 is this paragraph here, where they talk about the enthalpy change that occurs at the melting point when a solid melts is called the heat of fusion. Or more accurately, the enthalpy of fusion, or delta H fusion. So the amount of energy required for a phase change, in this case for water to turn into, for ice to turn from solid ice to liquid water, is called the enthalpy of fusion. Now, so what you have on the bottom of page 490 is a table. And if you notice water here, so what happens in this particular case is that water, the melting point, to melt water, it takes about 6.02 kilojoules for every mole of water molecules. Okay, now we were exposed to heat of fusion before. If you went back to your introduction, I had talked about the heat of fusion and heat of vaporization. So heat of fusion, again, is the energy required to melt a substance. Heat of vaporization is the energy required to evaporate a substance at its boiling point. Okay, so if you take a look on page 490, 491, they do talk about this heat of fusion or enthalpy of fusion. Also, if you take a look on page 490, let's scroll down, 492, they do talk about or expand a little bit more in terms of some of the vocabulary terms, like normal boiling point or normal melting point. And they do touch upon this idea of what is supercooled or superheated. So my recommendation is, as you go through this, do take a look on, reference it to your textbook So I've already put it here on the side. So page 187 to 190. So my recommendation is as you go through this first section, do have this out in your textbook, page 187 to 190, as well as page 489 to 493. So that gives you a brief summary from your textbook of what we had covered today. All right, folks, thank you very much. Have a good day. Bye-bye.